So let's say that we're told that we've created an angle, so it's in standard form, which means that we've started out here on the positive x-axis, and we've started rotating around to create an angle, and where the terminal side stopped goes through the point -4, 9. Okay? So, to help with this a little bit, I actually have a little bit of graph paper here because I know that it's not in your notes. So go ahead and take one of these little graphs. Plot the point -4, 9. Okay, and then just try to sketch as best you can what that angle is going to look like. So we're starting here with the initial side, and then our terminal side is going to do something like that. And go through that point right here, which is our -4, 9, right there. Okay? What we're asked to do is determine the exact values of the 6 trig functions of that angle. Okay, so it's not acute anymore. It's something that's gone past our 90-degree mark. So we're looking at an obtuse angle here that we'll call theta. Okay? Now, one of the kind of neat things about doing trigonometry on these rotational kinds of angles is that the answers that I get for this angle are the same as the answers I get for this one. And so there's actually a name for this. We use a theta with a little apostrophe after it, which in math is called a prime sign. So we say this is theta prime, and we call that a reference angle. So for any given angle, as I rotate around the circle, there's always a reference angle that is an acute angle made by the terminal side and the x-axis. So what that means in this case is that if I can find all the trig functions for this angle, they're the same trig functions for this angle. So even though what I'm being asked to find is really trig functions for this original, I'm going to actually find the trig functions for this because this goes back to being an acute angle. And we know how to deal with the acute angles. Because where were we using acute angles before? Where were we finding trig for acute angles? Or were we doing trig on acute angles? In the triangles, right? In the right triangles. So what that kind of leads us to then is, if this is an acute angle, then maybe I can create a right triangle, and I can just, in a sense, go back to what I already know. Okay? Which is exactly what we can do. From this point, I can drop down a vertical line like this, which is going to be perpendicular to my axis, so there's my right angle. And then if I, let's use red for that one, sort of close up the triangle by drawing in the side along the axis, I've just created a right triangle. So, what do I know about this right triangle? Instead of thinking about it as rotation, let's go back and think about it as a right triangle. What do I know about it? Sorry? Okay, but before I start using SOHCAHTOA, I'm going to have to actually get some info on this triangle, right? So Pythagorean theorem might come into play. So in order to use SOHCAHTOA, what do I have to know? The lengths, the sides, right? So, do I know anything about this leg? It's 4. Yeah, because I went 4 this direction to get to that corner, where I then went up to get to that point. Now, I'm still going to keep it as a -4, and I'm going to explain why in just a minute. So normally we don't label lengths as negatives, but because of us sort of superimposing this right triangle on our graph, we are going to think of it as negative because I went to the left to do it. So that side's going to be -4. Do I know what this side should be? That one's going to be 9. Positive or negative? Positive, because I went up for that one. Do I know what this side is? Have I been told? No, but can I find out? Yeah, so go ahead and figure that out. What's that hypotenuse going to be? Okay, got it? The hypotenuse is going to be from the 0, 0 out to my -4, 9 point. Root 97. Can that be simplified any more than that? Yeah, I don't think so. So we're just going to keep it root 97. Okay? All right, so now that I have the 3 sides of this right triangle labeled, I should be able to find all of my trig functions. So everybody have this that wants it? So I'm going to erase it to give us a little more room. Everybody okay with the definition? All right, so I need sine of theta. I need cosine of theta. I need tangent of theta. I need cosecant of theta, secant of theta, and cotangent of theta. All right, so what's sine going to be? opposite over hypotenuse, which is going to be sorry? 9 over. Yeah, so even though we're saying theta here, what we're really using is theta prime as our reference angle, and it's from there that we decide what's opposite, what's adjacent. And then this is actually our hypotenuse because here's where we've created that right angle. Okay, so we've got 9 over root 97. Can I leave my answer that way? No. So how do I fix it? So what should it really be? Good. Sorry? Why do I have to do what? Because general math rules are you can't have radicals in the denominator. So with my hypotenuse being the radical and it ending up in the denominator, I just have to simplify that out. Okay, how about cosine? Okay, so what's adjacent over hypotenuse going to give me? -4. Square root of 97. Can I leave it that way? Good. All right, how about tangent? So opposite over adjacent is going to end up? Do I have to fix that one? Nope, no roots. So we'll just leave it that way. Okay, how about cosecant? Okay, so what's that going to end up? Do I have to change that one? No, because the radical's in the numerator this time. That's not a problem. So I don't have to do any fixing on my cosecant when my radical's in the top. And again, that's why it's good to kind of just write out what sine was to start with before you fix it, because then going back to that and taking the reciprocal is a lot easier. Okay, the secant? Is it wrong if I move the negative up to the square root? No, remember negatives can go top or bottom or out in front. Just one of those three, don't double up. All right, finally, cotangent. -4/9. So by finding the 6 trig functions of this reference angle, I have also found the 6 trig functions of this original angle that I was actually being asked about. So these are the trig functions that I am interested in. Okay, does that make sense? Okay, try one on your own. So first draw it out, so you can use the second. There should have been enough for everyone to have 2 of the little graph things. So grab the second graph, draw what your graph would look like in standard position, going through that point -2, -5, and then label, draw the right triangle with the reference angle, and then figure out your 6 trig functions. how we're doing on this one. So this is what our original angle should look like. Everybody agree with that? Is that what you're working with? So we start on our initial side being on the positive x-axis, and then we're actually rotating around to get a terminal side that's going through the point -2, -5. Okay? What or where then is the reference angle for this one? The right side? Like this?
No. Up to
This?
Yeah.
So if I label this as reference angle, up to that y-axis, does that fit the definition I gave you?
Oh.
No. What's wrong with it? What part of the definition does it not fit? Yeah, it's always got to be between the terminal side and the x-axis. And that's important because if I try to use this as my angle, then when I set up my right triangle, the ratios get messed up. My opposite and my adjacent are not the ones that are supposed to be the opposite and the adjacent. Okay, so we have to make sure that when we're setting up our reference angle, whoop, wow, that was really big. I should have made that smaller. Okay, let me fix stuff here. But make sure that your reference angle is always between your terminal side and your x-axis, not the y-axis. Okay, so it's this part in here that we want for reference. Okay, so if that's the reference angle, then we're going to make the right triangle around that. So that should be one side. That's going to be the other side. What are we going to label this side of our right triangle? -2. And my green side? -5. And then what's my hypotenuse going to be? Square root of 29. Okay, so now we should have what we need. So what is the sine of theta going to be, Lucy?
-68.
Say again?
-68.
Where'd that come from? Why? Did we do any calculator stuff on that one? No. So we don't want calculator stuff. I want exact answers. It even says exact values. So as exact values, what should my sign be? Okay. Can I leave it that way?
No.
Nope. So fix it for me.
Would be -5 square root of 29.
There you go. That's what we want. That should be my sign answer. Cosine theta. Harry.
-2 square root of 97 over 97 up 29.
Okay. So that's already been fixed for us. Tangent of theta. Mackenzie. -5 over -2, which I can actually clean up a little bit and say just 5 over 2, because those negatives are going to become a positive. Okay, cosecant of theta. Taylor?
20. The square root of 29 is -5.
Okay, can we leave it that way? Yep, don't have to change that one. Secant of theta. Rebecca? Oh, she just left. Aaron?
Secant is root 29 over
And the cotangent, Peyton? Okay, makes sense? Any questions on that? Alright, so those are a couple of examples where we're specifically talking about a specific point that our terminal side is going to go through. But can we now generalize that? Can we take what happened in those two examples and try to come up with general little equations here that tell us what to do in these situations where we know a point that's on the terminal side? Okay, so if we look back at both of these examples, for sine, we were taking opposite over hypotenuse, right? Well, when I take the opposite of the opposite of the reference angle, in both cases, the opposite came from what? The what? The y value. Here, the opposite was the -5. -5 was the y on my point. Here, the opposite was the 9. 9 was the y from my point. So, in general, I'm going to take whatever my y coordinate is over the hypotenuse. Now, the hypotenuse, in order to give it a variable to represent it, oftentimes is represented as r. And the reason for that is, if you think about this point on the terminal side, back when it was over here, before it started rotating, wherever that point would be over here, as it starts to rotate, it's going to tick around like this and create a circle, right? So if you sort of imagine, well, if you've ever watched them paint the field before we got turf, and when they do the circles for the middle of the soccer field, and they'd have a string out about so far, and then there'd be that point, and they'd just go around the circle with their little paint roller, and that's how they would create the circle. So if you imagine that this point had a little bit of paint on it as it started to rotate around and create this angle, what it created was a circle. And so this distance that we often call the hypotenuse of our triangle also represents the radius of our circle that would have been created. And so when we talk about that distance in general terms, it's often referred to as r. Okay? So taking y over r is how I'm going to get sine. Opposite over hypotenuse, y value over r value. So then how did we get cosine? Taking the x over the r. Because the adjacent side was always the x coordinate from our points. How do we get tangent? Where did tangent come from? The y over the x. The opposite over the adjacent corresponds with the y coordinate over the x coordinate. All right, and then what do we do for these three? Just flip them. Yep. So this will be r over y, this will be r over x, and this will be x over y. So when you are given a problem where you are told that you have this point on the terminal side and you know what the ordered pair of that point is, the first thing you need to do is find the r. The r comes from Pythagorean theorem, which also comes from distance formula. So if you're someone who, is into formulas, r is always equal to the square root of x squared plus y squared. So you find your r, and then you can just set up whatever trig function you want based on this generalized formula for that particular trig function. If I want cosine, I take the x coordinate over my r. If I want tangent, I take y over x. If I want cosecant, I take the r over the y value. Now, if you don't remember all of that, you can always go back to drawing the right triangles like we were doing in the examples. But if you can start remembering this, it saves a bit of work. You don't have to work out the right triangle, just work out the ratio. Okay? But if you get stuck and you don't remember this, then just go back to drawing right triangles. Now, based on that, we can also talk about what kind of sign our trig functions are going to have in terms of being positive or negative. Okay? And that's important because they change by quadrant. In a right triangle, everything was always positive. Okay? But as we saw here, if we keep in mind that there are negative coordinates there for x and y, then it is possible to get some of our trig functions to actually be negative answers. So it would be nice if we kind of had a feel for when are things going to be positive and when are things going to be negative. And actually there's a really nice pattern to this. Okay? So if we're in the first quadrant over here, if sine comes from y over r, y coordinates in the first quadrant are always what? Positive. What about r? What's r always going to be? Positive, because it's the square root of x squared plus y squared. So no matter what x and y were, when I squared them, they became positive. Okay? So if I take y over r, y is positive, r is positive, then sine's got to be what? Positive. How about for cosine? Positive. How about for tangent? Positive. That's gold. And that should make sense because in the first quadrant all my x's and y's are positive coordinates, and so I should get positive trig values. Alright, but now let's go to the second quadrant. Y coordinates in the second quadrant are what? Positive. So if I'm looking for sine, I should expect sine to be positive. Cosine, that's going to be negative because in the second quadrant, x coordinates are negative. We're on the left side of the axis. So if cosine comes from x over r, and r is always positive, having a negative over a positive means I end up with a negative cosine value in the second quadrant. What about tangent? Which one? Negative, because y over x, if y is positive and x is negative, then tangent's going to have to be negative. And if we go back to that first example, where our graph did end up being over here in the second quadrant, that's exactly what happened. Positive, negative, negative. Okay, make sense? Okay, how about down here in the third quadrant? So now what's sine going to be? Negative, because over in the third quadrant, y values are negative. I'm below the x-axis, and so that negative over r is going to be negative. Cosine, also negative, because I'm still over here to the left. And then tangent, that's actually going to be positive, because having a negative sine and a negative cosine, when I set up y over x, is going to actually become positive. Okay, and then finally, and again, that's what this one was, right? Third quadrant, negative, negative, ended up positive. Okay, and then last but not least, fourth quadrant, what's sign going to be? Negative, because we're below. Cosine, positive, because we're back over here on the right side. And tangent, negative. Okay? So there's a little mnemonic that can help you to remember which trig functions should be what, depending on their quadrant. And the mnemonic goes like this. We start here in the first quadrant. All students take Chinese. In the first quadrant, everything is positive. In the second quadrant, the only positive is what? Sine, S. In the third quadrant, the only positive is tangent, T. In the fourth quadrant, the only positive is cosine, C. So all students take Chinese means that everything's positive here, only sine is positive here, only tangent is positive here, only cosine is positive here. Everything else is negative. Now, generally we talk about just these three, but then obviously the reciprocals act the same way. So if I know sine is positive, then cosecant will be positive. If I know cosine is negative, then secant will be negative. Okay? So that's really helpful then. When we have to decide, come back, there we go. When we have to decide what quadrant are we dealing with when there's certain characteristics going on. It also is helpful the other way around. If I know I'm in a particular quadrant, then what does that tell me about what the signs of my trig functions have to be? So if I tell you that the cosecant is positive, if I only told you that, could you tell me what quadrant we were in? If I only told you that I know the cosecant has to be positive, could you narrow down which quadrant we were in? Which one? Okay, but that's not a quadrant, right? There's two possibilities. If cosecant is greater than 0, that means sine had to be greater than 0. And there's two different quadrants that sine could be positive in. So I need this second bit of information in order to really narrow things down. So if I tell you the cosecant is greater than 0 and the tangent is less than 0, now can you narrow it down to just one quadrant? Can you tell which quadrant I'm talking about? Which one? I can't hear you. All I hear is If cosecant is going to be positive, greater than 0, and tangent has to be less than 0, which quadrant am I talking about? 2. Because cosecant is tied to which one? It's the reciprocal of sine. So we're basically saying sine has to be positive and tangent has to be negative. The only time I get that combination is in the second quadrant. How about if sine is negative and secant is negative? Which one? 3, because secant is the reciprocal of cosine. So we're basically saying sine is negative and cosine is negative. That only happens in the third quadrant. Okay? asked to find trig functions for a given angle, there's two parts of the answer we have to be concerned about. We have to be concerned about what the actual ratio is, and then we have to be concerned about whether it should be a positive or a negative based on the quadrant we're in. Okay? So if I tell you something like this, I know that the cosine of theta is a negative 5/8. I also know that theta lies in quadrant 2. And my task is, I'm supposed to come up with the 6 trig functions for that. The first thing you want to do is make yourself a quick sketch. It doesn't have to be on actual scratch paper or graph paper, excuse me. It doesn't have to be exact. It's just to give yourself an idea. If this is a quadrant 2, I've got some kind of graph that looks like this. Starts here in my initial and goes up here into quadrant 2 somehow. Okay? If that's the case, then that means the reference angle is right here. And so the triangle we're talking about would be something like that. Make sense so far? Following what I'm saying? So if I know cosine is negative 5/8, what does that tell me then about my triangle? They tell me my cosine is negative 5/8. What's that tell me about my triangle? I already know I'm in the second quadrant. I was told that. So that's what I drew. But now what do I know about my triangle based on given the information that cosine of theta equals negative 5/8?
Hypotenuse is 8. The base is negative.
Okay, because that would be the adjacent, right? Which would also be our x coordinate if we were talking about a point, that kind of thing. All right, so if I know now that the hypotenuse or my r is 8 and the base leg or my x value is negative 5, can I find that?
Yes.
Yeah, what's it going to be? 64 minus 25? 39? Sound right? So square root of 39 is that side. Now can I find my trig functions?
Yeah.
But now when I do my trig functions, I have to keep in mind what the signs are supposed to be in the second quadrant to make sure that that's how I'm writing them. So sine is now going to be what?
Square root of 39 over 8.
Cosine was already one I had, so I don't have to write it again. If you want to, just to keep the pattern, that's fine. How about tangent?
Negative 5 over square root. Oh wait, so negative 5 square root.
Close.
39. 39 over negative 5.
Yeah, we gotta go opposite over adjacent on tangent, right? So the root's gotta go on top. All right, cosecant. Secant. 8 over negative 5, negative 8 over 5. And cotangent. Okay, and what should happen with signs in quadrant 2? So my sign should be positive, and then a reciprocal positive, that's good. Cosine is supposed to be negative, which it was, and that makes secant negative. How about tangent? What's that supposed to be in quadrant 2? Negative. So I got negative, it's all good. Okay? That's what you're going to be doing in the homework. Basically, the types of examples we just saw here are the types of problems in your homework. So if you're feeling good about this, homework should be pretty easy to do. That's going to be due on Tuesday. Yeah, I'm not sure if it's posted on Canvas yet, but it will be in a couple of minutes. I'm not sure I made it published yet, so it'll be there in a couple of minutes if you've got a study hall this afternoon. That'll be due for Tuesday, okay? All right, have a good weekend.
It was on Friday, right? So we have another
Yeah,
lesson.
whatever Canvas says. I think Friday because Wednesday's PSAT pushes everything,
Yeah.
so Friday sounds about right.
Oh, my God.